In this lesson, we're going to take a closer look at how atoms become ions in the first place, because you need to have ions in order to study how ionic compounds form. So it all begins when a metal atom meets up with a nonmetal atom. And the thing to remember here is that the metal atom is neutral but unstable. And the nonmetal atom is also neutral but unstable. So let's take a look at what that means. It seems kind of counterintuitive to be neutral but unstable. Most people, you would naturally think that if it's neutral, it's stable, but that is not the case. So if this is indeed calcium, it would have to have 20 protons. It probably has 20 neutrons, but I'm going to ignore neutrons because neutrons don't contribute charge. So if this is an atom, we're implying that it is neutral, which means it would have to also have 20 electrons. And if we see these electrons, if we count them, there's 2, and then another 8, and then another 8. So this is a total of 16, there's 20 electrons here. But taking a look at these 2 electrons, right, there are 2 of these 20, 2 are valence electrons. And this is why it is unstable, because only having 2 valence electrons is an unstable situation for an atom. An atom wants to have 8 valence electrons. So the problem is calcium atom can't give up these 2 electrons unless there's somebody else, another atom, that is willing to take on those 2 electrons. So that's where it begins, when a metal atom meets a nonmetal atom. Okay, and so what we have here is this is oxygen, so it is going to have 8 protons. Again, I'm going to ignore the neutrons. They don't contribute charge, and that's what's important here. And we should notice, if we count up, there are 8 electrons here. So it is neutral, but there are only 6 valence electrons. Therefore, this atom is unstable. So what this atom is going to, so let's mark this down, that of those 8 total electrons, 6 are valence electrons. And so these 2 valence electrons are going to be given away, and the oxygen is going to take them, and then both the calcium and the oxygen become quite happy and stable. So let's take a look at what happens here. I'm going to make sort of a funny little arrow here to show that these 2 things are going to come together and move down to look like this. So what will happen here, the calcium atom will lose 2 electrons. This is, of course, oxidation. The oxygen atom will gain 2 electrons. This is, of course, reduction. And if we're showing it up here, this electron might come over here, and this electron might come over here. And now what we have is the calcium ion, right? It's no longer neutral, it's a charged particle. And if we consider this, this is still going to have 20 protons, but instead of having 20 electrons, it's now down to 18 electrons. And if you remember, protons minus electrons is going to give you the overall charge of +2. So protons minus electrons is going to give you an overall charge of +2. Oxygen, on the other hand, had 8 protons. That hasn't changed. But now, with those 2 extra electrons, it now has 10 electrons. And if we take those numbers, protons minus electrons, we're going to see the overall charge is a -2. So the calcium ion, by losing 2 electrons, it has become a cation. And the oxygen atom, when it gained 2 electrons, became the anion. And it is that attraction of the oppositely charged particles that is the ionic bond, that electrostatic attraction. Okay? So the ionic bond is formed between the cation and the anion in what we call an electrostatic attraction. Overall, the ionic compound will end up being neutral, right? Because a +2 and a -2, that's going to cancel out. And that is the overall, that's the goal. Hashtag goals. The chemical formula here, because we needed just one of each, one calcium and one oxygen, we are going to write that formula as CaO. And we will refer to this not as a molecule, we will refer to it as a formula unit. Okay, take a look at the back side. And we're going to review Lewis dot diagrams. Lewis dot diagrams represents the number of valence electrons as dots. Right? Valence electrons, the number of valence electrons, we're going to show them as dots. They are going to be used to show how atoms become ions and how an ionic compound forms. Okay? This is here as your reference. If you've forgotten, everybody in column number 1 has one valence electron. We draw that as a single dot. Right? This is group 1, group 2, and then it skips over to group 13, 14, 15, 16, 17, and 18. If you're wondering what happened to groups 3 through 12, they belong in period number 4. This is period 1, 2, 3, and 4. And so because groups 3 through 12 only start in period 4, we're just leaving those out for simplicity's sake. So we can see here that anybody in group 13 is going to have 3 valence electrons. Anybody in group 14 is going to have 4 valence electrons. Group 15, 5, 16, 6, 17, 7, and 18 will be 8. The exception, of course, is that helium can only have 2 valence electrons. Okay, so using this, we are going to show how sodium and phosphorus atoms are going to become ions and show what those Lewis structures will look like as they form in the ionic compound. So if we start with Na, which is a 1 valence electron, and then right next to it I'm going to put a plus sign, and we're going to put phosphorus. So phosphorus has 5 valence electrons. Okay, so the metal, sodium, is going to lose that 1 electron, right? But if it loses that 1 electron, it might sit here with this unpaired electron of phosphorus, but phosphorus still has 2 other unpaired electrons, and it's not going to be satisfied. So sodium has to bring in a few friends. In fact, 3 total friends, each one bringing a single electron. All 3 of those single electrons are going to go sit here. And I'm going to make these different colors just so we can see the origin of each one of these. Right? And so you can see that this electron's going to go here, this one's going to go here. It doesn't matter where, but these are the 3 electrons that are going to pair up with those 3 singles. So this is what we start with. These are the neutral atoms that are unstable. What we're going to draw over here are the is the ionic compound, which is going to be, in the end, the ionic compound as a whole will be neutral overall, and stable. Okay. So let's see what we're talking about here. I'm going to start with phosphorus because it can do the most things here. It's got 3 things that it needs to work on. So I'm going to start with the phosphorus. I'm going to start with the 5 electrons that it originally had. And now I'm going to show, using my other color pen, to show where those sodium electrons ended up. Because of this, phosphorus now has a -3 charge, right? And that is not neutral, but we are not done yet. Because when this sodium lost this 1 electron, it now has 0 valence electrons. Technically, it has the next layer down, but the layer that was existing before is now empty. So we're going to leave it empty, and we're going to show that as the overall +1 charge. But now we're going to, because we wouldn't want to put another positive ion right next to a positive ion, we're going to put these 3 positive ions surrounding the negative ion, because that's likely what would happen. We want to spread out the positive ions as much as possible. So this is how we would draw the final ionic compound product. There's 3 sodiums that are needed to 3 sodium ions that are needed to cancel out with the 1 phosphide ion. So the final formula unit is going to be Na subscript 3, because there's 3 of them, followed by the P for phosphorus. So that's the final ratio. We need 3 sodiums and 1 phosphorus. Overall, this ionic compound is stable. It is neutral overall, even though it is made up of charged particles. But those charged particles cancel each other out, so overall the compound is neutral. We're going to look at one other example here between aluminum and nitrogen. Let's start with aluminum, which is going to have 3 valence electrons. And again, I'm going to draw them in a different color just so we can follow them like we did with the previous example. And nitrogen has 5 valence electrons. Right? These are neutral atoms. They are unstable. Nitrogen needs 3 electrons. Aluminum has 3 electrons. So this is a really lovely match, because all 3 of these electrons are going to be lost by the aluminum, and all 3 are going to end up on the nitrogen. So what we have left over, aluminum now has 0 electrons in that valence shell. So we're just going to draw it, its valence shell is empty with no dots. And overall, because it lost 3 electrons, overall it will have a +3 charge. Nitrogen, on the other hand, I'm going to start by drawing the original 5 electrons that it had. And I'm going to bring in those 3 purple electrons that were originally on the aluminum. And now this nitrogen overall has a -3 charge because it gained those 3 electrons. Right? And so we only are going to need 1 of each of these, because the +3 cancels out with the -3. So overall here, what we have here these were neutral atoms that were unstable, and they turned into an ionic compound. It is overall neutral, and it is now stable. The final formula unit, because we just need 1 of each, we would write it as AlN. All right, so in this lesson, we learned how atoms become ions, and we learned how to show them using Lewis dot diagrams. Stay tuned for one more video in this series. Otherwise, I will see you back in the classroom.